Thompson Construction Group's electrical safety training. Take a second and think about just how important electricity is in our daily life. Imagine how difficult our work would be without it. The fact is, electricity is a very common part of our everyday life, and like so many things we use often, we overlook both its importance and the hazard it presents. Whether you work in the field or in the office, you can be sure that you'll use electricity in countless ways at Thompson. Our goal is that you not only understand its value, but that you understand its characteristics, strength, and dangers. You can work safely with electricity and avoid some potentially very dangerous situations. Electricity functions within the confines of an electrical circuit. A basic, completed electrical circuit requires 3 elements in order to function. The first is the electrical source. This can range from a battery to a large transformer outside that converts the high voltage carried by power lines into a lower voltage that can be used by our machinery. In the above diagram, the battery is the electrical source. The electrical user is what provides the significant resistance in the circuit. In the diagram, the bulb is the user. Finally, we have the wires. The wires are vital because they connect the electrical source with the electrical user. If the wiring operates with too much electricity, it may overheat and fail. This could result in an electrical fire. Electricity will travel only in a completed circuit. When you flip a light switch off, you are breaking the circuit. To turn the light back on, you complete the circuit by flipping the switch on. Electricity always travels the path of least resistance. Every electrical user has a certain amount of electrical resistance. If the electrical circuit has a choice between a light bulb or a power tool, it will enlighten the bulb because the bulb has less resistance than the power tool. Finally, electricity will always travel to ground. Ground completes a circuit and offers very little resistance. Electricity will travel through a person because most often that person offers less resistance than the electrical equipment being used on the circuit. If a person is touching the ground, he will form a completed electrical circuit. At that point, the electricity will prefer to travel through the person, then to the ground. This explains a bird's ability to sit on high voltage power lines. Because they're not touching the ground, they do not form a complete circuit, so the electricity does not pass through them. Let's cover some basic electrical formulas. On a given circuit, voltage is consistent. What changes is the resistance, which in turn changes the amps. Amps are what we need to be concerned with, as you'll soon see. According to the formula, as the resistance goes up, the amps will decrease, and if the resistance goes down, the amps will increase. As you can see, the same resistance on different voltage circuits will result in different amps. When the voltage increases, so do the amps. Notice the number of milliamps an average person can be exposed to with the typical home voltage of 110-120, 60 milliamps. Remember this number for the next slide. Voltage describes the rate at which electricity is drawn from a source. 1 unit of electrical current is called an amp. 1 milliamp, or 1,000th of an amp, can be felt by the human body. 2 to 10 milliamps will give you a minor shock and may result in a fall. A jolt of 10 to 25 milliamps will result in the loss of muscle control and may not allow you to release the current. 25 to 75 milliamps will be painful and may lead to collapse or death. A quarter-second shock of 75 to 300 milliamps is almost always immediately fatal. Because the skin offers most of the body's electrical resistance, the point of electrical contact with the skin will determine the amount of shock received. Remember, the higher the resistance, the less milliamps of exposure, which means a lower amount of shock. Resistance is increased if you are shocked in an area that has thick or calloused skin, or if your skin is very dry. Your resistance decreases, thus increasing your shock, if the electricity contacts you in an area of thin skin, if the skin is very wet or sweaty, or if the skin is broken. Because every human body is built differently, everyone has different levels of resistance. The range can be from as little as 500 ohms to as many as thousands of ohms. This is why a similar voltage shock can feel minor to one person and be deadly to another. Of course, there are other considerations. For example, one person might have a heart that is more sensitive to ventricular fibrillation than another person's heart. The primary way to protect yourself from electrical hazards is by using PPEs that increase the resistance offered by the body, thus decreasing the number of milliamps you're exposed to. Of course, you'll want to make sure that the PPE being used is properly rated for the voltage that you may be exposed to. Gloves provide increased resistance at the most likely point of electrical contact. Shoes and mats increase resistance by making it more difficult for current to reach the ground. Also, there are hard hats constructed of special material that can provide electrical protection. OSHA divides workers into two categories when it comes to working on or with electrical equipment: qualified or unqualified. Qualified workers can perform work on electrical equipment. They know how to identify exposed electrical equipment and energized parts, how to lock out or tag out equipment so that it can be worked on safely, and how to safely troubleshoot electrical equipment and parts. Unqualified workers are not permitted to work on any electrical equipment or make repairs to electrical equipment. They only receive the training that has been discussed in this session, which includes how electricity works, how electricity can contact and harm the human body, which tasks require a qualified worker to perform, how to identify potential electrical hazards, and how to use equipment and machinery that is powered by electricity. Remember, at Thompson, your safety is extremely important to us. You should never perform work of any kind, including electrical work, that you are not trained to perform. Electrical systems, when designed and built properly, are the safest forms of energy. Electrical systems are inherently safe. Injuries typically occur when improper procedures are used to work on electrical equipment, the hazards of electrical systems are not understood or not taken seriously, or when safety systems are ignored or circumvented. This is why it's so important for you to identify and understand the hazards of electricity. Always inspect equipment before using it, and always use equipment only as it was designed to be used. Always stay at least 10 feet away from high voltage power lines. High voltage lines are bare conductors, so contacting them with a ladder, cherry picker, man lift, bucket truck, etc. will cause electrical shocks. If a dump truck were to touch high voltage power lines when it raised its bed to unload its contents, the driver would not even feel the electricity because the large rubber tires would prevent the voltage from reaching the ground and forming a complete circuit, much like the bird sitting on a wire. However, if the driver were to step out of the truck, he would be electrocuted as soon as his foot touched the ground. Damaged wiring insulation exposes hot wires to potentially combustible materials and may start a fire. Always contact your local utility companies prior to doing any digging or trenching and have them mark the location of wires. Broken switches or plugs can cause overheating in the circuit. Overloaded circuits are created when too much electrical current is running through a given electrical system. Appliances or tools can become overheated if they have an internal electrical problem. Static electricity can cause discomfort for workers or even start a fire or explosion when around flammable materials. Make sure flammable materials are properly stored and grounded, especially when chemicals are being dispensed. Portable power tools are used by almost everyone, either at work or at home. They require proper care and inspection to reduce the risk of electrical danger. Some things to look out for are damaged wire insulation, broken plugs, overloaded circuits such as a device that pops a fuse when turned on, overheating or sparking. If you find a power tool that is damaged, tag it out of service and place it in your supervisor's possession so that it can be repaired or replaced. Never use portable power equipment in wet or damp areas. Doing so is basically asking to be injured, since the chance of an electrical shock is much greater in wet conditions. If a power tool appears to be getting too hot or starts sparking, stop using it, tag it out of service, and have it repaired or replaced. Like other electrical equipment, extension cords pose their own electrical hazards. They too should always be inspected before use. Also make sure the cord is rated for the load that you plan to put on it. Is the extension cord rated for outdoor use? If not, the cord could overheat, start a fire, or trip a circuit breaker. Remember, extension cords are designed only for temporary work. They are not intended to be used as a permanent power source because they're more likely to be damaged or overloaded, and they're not supplied with their own circuit breaker as a hardwired system would be. Extension cords are not ropes. They can easily be stretched and damaged if used to hoist objects. Do not use staples or nails to hang extension cords because this could cause damage to the outer jacket insulation. If the wire becomes exposed, the current could reach ground through the nail or staple and cause a short-circuited and hot cord. When unplugging a cord from an outlet, always do so at the plug. Yanking the cord from across the room is an easy way to damage it. Keep a few things in mind when inspecting electrical cords. Examine the plugs for deformed or missing pins. Inspect the outer jacket insulation of the cord for cuts, abrasions, or signs of wear. Is there evidence of internal damage, such as a pinched or crushed outer jacket? Again, if a cord is damaged, tag it out of service and repair or discard it. We do a lot of welding at Thompson, and like electrical cords, welding leads must be inspected prior to each use and tagged quarterly. According to OSHA, welding leads cannot have any damage to its insulation within 10 feet of the electrode holder and 10 feet of the connection to its source or any other connection. Any damage to the insulation outside of the 10-foot parameters is permissible only if no conductors are exposed. OSHA also requires that damaged welding leads must be taken out of service and replaced. They cannot be repaired. At Thompson, all electrical equipment, including power tools, must be inspected for damage before each use. Also, every 3 months it must be inspected thoroughly by a competent person and tagged with color-coded tape according to the Thompson color coding policy. Circuits are protected with equipment such as breakers or fuses. These allow a certain amount of amperage in the circuit before blowing, tripping, or otherwise breaking the circuit. They're used to protect equipment and wiring in the system from being damaged by too much electrical current. Energize, close the circuit, or de-energize, open the circuit with the appropriate equipment such as switches or breakers. Do not open or close circuits by installing and removing fuses, taking terminal lugs on and off, or by splicing cables. If a circuit protection device is tripped, have an authorized worker inspect the system before manually re-energizing the circuit. There may be a short or some other electrical hazard that needs to be repaired. Almost all electrical equipment is designed with some sort of grounding system so that if there is a problem, such as a short circuit, the electrical current will go to ground through the grounding system rather than through the human body. Do not use equipment with damaged grounding connectors. Some people might alter a 3-prong plug by cutting off the grounding prong so that they can plug it into a 2-prong receptacle. This practice is not safe because they are bypassing an equipment safeguard and setting themselves up for an injury. Another mistake is using an adapter to convert a 3-prong system into a 2-prong system. Again, this interrupts the grounding connection. The adapters are not designed to send the current to ground if there is a problem. Ground fault circuit interrupters, or GFCIs, reduce the likelihood of fatal shocks by automatically switching off the power when a small amount of earth or grounded current is detected. GFCI receptacles might be found in homes or hotels, in the bathroom or kitchen, where an electric appliance such as a hairdryer or toaster has a chance to fall into a sink full of water. If this occurred, the GFCI would automatically shut off the power to the receptacle. The receptacle would have to be manually reset. GFCIs can also be portable and used with extension cords and power tools. Fuses and circuit breakers operate at several amps to allow the circuit to continue even when slightly overloaded. Remember, people are injured at the milliamp level. Static electricity is very common in the workplace and at home. It's caused when two materials rub against each other and build up a charge of electricity. The static is finally dissipated when a grounded conductor, such as a doorknob, is touched. Sometimes static electricity can result in arcs of electricity leaping from a person onto an operator's metal console. This type of static electricity can cause minor skin burns. It can cause dangerous shocks for people with heart conditions. Static electricity can be reduced by properly grounding the equipment, providing rubber matting for the operator to stand on, or providing PPE such as grounding wires that connect to the worker's wrist, gloves, or shoes. Flammable and ignitable materials include flammable gases, vapors or liquids, and combustible dusts. All of these can be ignited by even the smallest spark of electricity. People have been killed and seriously injured by the ignition of a flammable substance by a static electricity spark. Rooms that permanently use or store flammable substances require special explosion-proof electric systems, such as lighting and outlets. Do not use portable power equipment in rooms that are known to intermittently contain flammable substances. In conclusion, remember, electricity will try to reach ground even if it means going through a person. Even the small voltage from your home can cause serious injury. Always inspect power tools and cords and do not use them if damaged. Do not attempt to repair electrical equipment unless you are trained and qualified.